So a little bit of an advance forward here. I give a lot of these, obviously. And I have a kind of a generic one I refresh before I give it, but it's pretty much all the same, except when I give it to a local club, I put in a lot of locally specific information. I did it for the settlers last week and I did it for this week. So there's a lot of slides. But fear not, most of them are pretty pictures. So anyway, let's get into it. That's all my stuff. Been around here since forever. Been doing digital since CW. Anyway, what I want to talk about first is modulation rates for digital modes, not throughput. For those of us who are old enough to remember dial-up modems, you never got 56K from a 56K modem. Your throughput would be sometimes substantially less than that. So it's pretty much the same with all of these. We can start with good old packet radio, 1200 baud. And for the type of modulation they use, 1200 baud, or 1 baud is 1 bit per second. In modern terms, that's 0.0012 megabits per second. It wasn't especially fast 40 years ago, and it hasn't improved. Backdoor 4, HF can do 3 to 5 kilobits per second. That's better. VARA is a software modem using a fairly sophisticated modulation protocol. It's available for both FM and HF. On FM, with the right equipment, you can do up to 25 kilobits per second. Not too shabby. AREDN ham radio network links can do up over 100 megabits per second. The way we have it configured here locally, the max is about 74.2 megabits per second. But again, that's just the modulation rate. That's not the throughput. The software, as of today, supports over 100 different models across 4 brands. Ubiquiti, MikroTik, TP-Link, and GL.iNet. Across 900, 2.4, 3, and 5 gigahertz. And there's asterisks all along there, and we can talk about this later. If you happen to be in an RF pole, which a number of you are on AREDN, you can link through the internet, tunnel to another node that does have network connectivity. And I call that the AREDN starter kit until you can get an RF link going. The AREDN code allows operations in Part 97 only channels because you've got your ham radio call sign in it. And also under Part 97 regulations, which has a kind of a subtle benefit. Because ham radio operators are not necessarily sophisticated with network configuration, the AREDN software provides a domain name server and DHCP, which assigns IP addresses. It also does route discovery and routing information, so you don't have to futz around with BGP and God knows what else. And all of those combined make it pretty easy to get one of these on the air, get it configured and on the air. So when the AREDN software is loaded into these wireless access points, we call them nodes, for lack of a better name, and no hacking required anymore. Thank God. Makes the entry level into this pretty easy. You buy an off-the-shelf wireless access point that's supported by AREDN. Follow the wonderful instructions on the website, and I'm not being sarcastic. They are wonderful, and you're up and going. And when you put the AREDN software on them, they create a ham radio TCP/IP network. They find each other, they discover routes, and boom, you've got the internet with a little I, powerful sign. And you have to kind of consider them like handy-talkies. Typically, the max power is about 600 milliwatts. So, like a handy-talkie, you normally end up talking to a mountaintop site. For the handy-talkie, it's a repeater. With one of these, it's another node at a higher elevation. If your node happens to hear multiple nodes on the same channel, it'll always pick the best one. So no point in using an Omni. Get a directional antenna, a dish, typically, and just point it at the best one and you're done. So you've got this awesome network built but it's just a network. It doesn't do anything. All it does is let you get to services. And here are some of the things you can put out. None of these are unique. They're all run out on the internet. But we've tested variations of all of this around here locally. We don't necessarily use all of them now, but they all work fine. So anyway, all of those there, all of these here. Plus, anything you want to put on this network subject to the Part 97 regulations. So some quick and dirty examples. This is Mattermost. It's a text and pictures. This particular one is run by Eric, KG6WXC. This is kind of an interesting screenshot. He and his wife and young daughter were out camping near Ridgecrest the night of the 7.1 earthquake. They were in a tent. They got bounced around a lot, but no injuries. The next day, Eric drove over and took a picture of the surface rupture, and he shared it with us. Well, the mesh network doesn't get out into the high desert. So how did he do it? Well, there's Part 15 wireless out there, your regular wireless, and he has two Mattermost servers, one on the internet, one on the mesh network, and they're tied together. So he took a picture of it, shared it with Mattermost on his phone, and we got to see it over on the mesh network. Pretty slick. VoIP is no big deal, voice over IP. This picture's getting to be really old. When we were deploying the backbone, Paul WD6BI was the thrust behind that. He wanted to get a VoIP PBX up and running, but he was not up to speed on Linux, so we didn't consider any kind of Asterisk-based server. He's doing better. So we bought this turnkey Grandstream. Yeah. $275 or something like that. Supports 256 extensions. I don't know, 64 simultaneous conversations. Bought that. It's pretty easy to configure if you understand telephone systems. Stu can tell you that there are exceptions upon exceptions, and they support legacy back to turning the crank and talking to the operator correctly. So they can be really complex to configure. So anyway, we got this one configured and deployed. Here's a picture of it in a rack on Sulphur Mountain. It's since been moved to South Mountain, but I don't have a picture there, and it's buried back inside a rack. So it wouldn't be very interesting anyway. We have about 30 extensions up there. Most of them are hams, but there are a few served agencies. Wherever we can drop a mesh network link into a served agency, we give them a VoIP telephone and an extension. And because it's a Grandstream, we've been recommending people use Grandstream phones. They're not expensive. If you can read it, it says, "I missed a call." And if it was video, you see the red light blinking. Somebody left me a voicemail. That's nothing special. Every VoIP PBX has all sorts of features, and we have them too. The call waiting, call forwarding, all sorts of good stuff. A collaboration server, that's the label they give to those servers that you see the gamers use on TV and video, keep in touch with their teams. Some examples are TeamSpeak, Mumble, TeamTalk. If you go to Wikipedia, it's got a list of over 24 of them.
Yeah, Discord's the common one.
I'm sorry?
Oh, Discord's the common one now.
Yeah. But we chose an open source one. Or not open source, but free one. They all have those features: file sharing, desktop sharing, voice and video chat, and I'm sure there's a lot of other features. We chose TeamTalk because it's one of the few that doesn't mandate encryption. So we got to avoid that whole discussion. Got chat rooms, many to many, one-on-one chats on separate channels. You can set up as many channels as necessary. I have an example of that. You can use a speaker and microphone on your laptop, or use a USB headset for better audio quality. Full duplex means you can interrupt the person's talking. You don't have to wait for them to time it. And because we have multiple channels, you can have a conversation while somebody's chatting on another channel. You don't have to wait for those two to finally shut up and let you use the repeater. It's not 300 or 3000 hertz communications grade. The codecs and the phones will shift up to the highest quality they can. Typically, that's high quality. It's those of us whose hearing may not be quite as good as it used to be. It's a boon to listen to. PTT, Vox, or open mic, we use standardized kind of on left alt to use push to talk. Open mic means you can take a specific channel and take two laptops, like at a fire camp and another camp, and put a couple laptops in quiet rooms and nail them up. And somebody can come up to one of the laptops and say, hey, I need to talk to the fire captain. Somebody on the other says, hang on, I'll go get him. It's a what they call the nailed up connection. Vox works fine. We have a weekly net, and on those nights I'll close the doors in the office, plug in my USB headset, put it on Vox, put my feet up on the table, and just yak away. Very, very natural. There's a Team Talk application. It's available for Mac OS, Linux, Windows, whatever. You can see the people logged in on the left. When somebody's talking, the background behind their call is green. When they stop talking, it goes to yellow. So you can see that Dave Cam Success Cube was the last one to talk. Up at the top, we've got 4 tabs. Chat, video, desktops, files, are what you would think they are. This happens to be the chat tab. And we don't find that video adds a lot to a net. We do occasionally have everybody enable their cameras so we can stress the network and the server. The thumbnails here are 640 by 480 typically, 10 to 15 frames per second. It's fine. Let's see, left channel, me, Rusty K1 GGS, bottom WA6GNB, middle is K6 CCC, middle is Eric KG6 WFC, down at the bottom and middle is Dale, forget it's called. He's out in Cathedral City. Upper right is Kevin, AJ7C in Culver City. Unlike voice, which only transmits from the dot, these are continuous streams. I think each one's about 100 kilobits per second. So you got 700 kilobits per second up and then 700 kilobits per second down. Server's a Raspberry Pi 3. And while we were doing this particular test, CPU utilization was 10%. And network utilization was also 10%. So it's a lot of fun. I want to talk a little bit about this. Is Ben here? AREDN? Okay. In early 2017, we were busily pushing out a backbone across Ventura County as the AREDN code had matured enough to make it stable and make it work. In, I think, September of 2017, Ben emailed me a link to an article on how to stream webcams to YouTube. And he told me, see if we can make this work. It might come in handy someday. Well, I messed around a little bit and sent him a live YouTube stream of my test camera in my driveway. Big deal. So anyway, I put the article away. Well, December of 2017, he paints me and says, hey, we got a fire going up near Santa Paula. Thomas Fire near Thomas Aquinas College. He says, don't you have a camera up there? Yeah, different brand camera, different model camera, different OS. I logged in and managed to get it working in pretty good order. And this is what you saw. We streamed the fire out to YouTube for an hour and 45 minutes. And at that point, the wind, which was howling, it was one of those hot, dry Santa Ana days, took out Edison. And at that point in time, we didn't have backup power anywhere yet. So let's see if this works. I got to get a better one. Anyway, the fire came down here. This light was the owner's driveway. This is a 46-acre private property. The north edge of the property was about 50 to 100 yards north of the tower. Fire came down here, burned here, burned right across his north edge of his property, continued west and ravaged the town of Ventura. They lost hundreds and hundreds of homes. Lessons, well, anyway, few days after that, got an email from an inspector, Ventura County Fire Department, asking for the URL of the video. It's still up on YouTube. I sent it to him, and he thanked me. Never heard anything directly, but we did hear a little bit later that they found the video useful because it was the first video of the fire, and they used it for some of their analysis. In June of that year, ham radio month, Ventura County Board of Inspectors, thank you, supervisors, I assume, gave out the usual proclamation, but in it, they specifically mentioned this video. So we got some good press out of it. So lessons learned for the rest of that year and into 2018, we started hardening the sites, better RF links, batteries at least, solar in a couple of places, better cameras, more cameras, and sure enough, Woolsey fire. For those of you who aren't familiar with the area, this is Simi Valley, and this camera is on the very north end of Sycamore, so the north edge of the valley, and it's looking southwest. Woolsey Canyon is about 3 screens off. Actually, my son and I saw it break out that morning, and it proceeded across another hot, windy, dry day, came across, made a run. Oops, I got the wrong button. Hang on. Something working. Yeah, made a run across here, east to west, then turned and headed down here. Fire department was staged here, and they fought it off. Wind turned, it ran back up over the hill, back down into Thousand Oaks, lost several hundred other structures, continued south through Malibu, and like it always does. So we actually streamed this one for about a day and a half to YouTube. And Ben, AI6YR, has a huge Twitter following, disaster communications and weather, and he put the URL out, and we saw average a couple hundred people checking in and out, watching it from time to time. And we heard back that they found it sometimes more useful than the traditional media because it was obviously real time. We haven't had any large fires like that yet since. Well, we had some small ones. Had fun videoing this one. For those of you who don't recognize it, that's the 118 freeway in the Santa Susana Pass going over into the San Fernando Valley. A fire broke out there. We get lots of little fires along that freeway during the summer. Anyway, you can see the helicopter doing the water drop, and you look closely, you can see the strike beam that the previous helicopter dropped off. Anyway, they knocked it down in a couple hours. This happened to be, camera was looking right down on it, Chatsworth Peak. Yeah, rest in peace. Anybody argue with this? Anybody ever transmitted a single-spaced handwritten list of medicines? It's ugly. If somebody was able to hand you a text file on a thumb drive and here, send this, piece of cake. So there's a couple ways to do it. Plain old vanilla email servers and clients, just configured for the mesh network. And you can use Thunderbird or any other email app you want to use, or a web client we have. This is my Thunderbird. At the top, you can see my Gmail account, but down at the bottom, you can see my local.mesh account on K6PDR-mail. And by the way, Eric struck first. He now has the meshmail.org domain for inbound mail. So we can send in, and whoever's out on the internet can reply. It will come back out to your mesh network. And this is Roundcube. It's the webmail interface. Works pretty good. These are the people who are just coming out of beta. These people have accounts. If you want to get an account, drop me a note, I'll set it up. Before I talk about WinLink, WinLink has its purpose, but it has some limitations. It's got a file size limit, and it needs it because it might transmit HF. And data rates are variable depending on what you're using. And going point to point is a bit of a pain because, correct me if I'm wrong, Stu, both ends have to be set up for point to point.
Yes, both have to be active and full.
Right. Whereas under the mesh mail, obviously you're running at quasi internet speeds and there's no size limit. I'm thinking, well, they both have their place, but I'm thinking for local emergencies where you need to send something to somebody in the county, this is the best way to go. And all we have to do is set your account up on the server and point you at the web interface. You're off and running.
The only comment I'd make is providing how big that donut hole is.
Yes.
The real
Yes.
advantage of WinLink, and
Yes.
I said WinLink was a program I absolutely said I never used until I realized that with HF, I could reach into another state.
Yes.
And if I'm trying to get up to Sacramento
Yes.
with a message, that unfortunately is my best choice.
Yes. No argument there. They're both tools. You know, how to take advantage of both. And by the way, just this has nothing to do with it. We do WinLink check-ins on Tuesday. Last Tuesday I did Telnet, big deal. VAR FM, VAR HF.
Packet.
Yeah, thank you, packet. I always forget that one. And the mesh network, 5 separate check-ins. I think it's a high watermark. So anyway, anybody not know what WinLink is? Good. I'll tell you what it is. Anyway, originally for voters, originally used those automatic linked establishment radios, commercial, really pricey. But since then, they've adapted all of those there. The asterisk by Pector 4 is a little reminder, if you didn't know already, it's only legal during FCC declared emergencies in the US. I think it's legal everywhere else. Anyway, VAR HF, I mentioned the software modem. RDOF is an older software modem with substantially poorer performance. So it's falling rapidly out of favor. On VHF, packet radio, APRS, who knew? VAR FM and AREDN networking, if you've got it, is much faster. And you don't have to specify digibeters. It knows the route to the post office. So it's pretty straightforward. It has a large set of standardized message templates, ICS, USPS, FEMA. There are state-specific ones, and they're always updating. Saw one hit this morning. I stole this from the winlink.org site, used my marvelous graphics editing skills to bring it current. But you get the idea. This is WinLink Express. Looks pretty much like your vanilla email app, but specifying where it's supposed to go and how it's supposed to go is a little complicated because if you want to go via packet radio, you can specify, I don't know, how many different digit beats? 3, 2?
Well, you can actually script it.
Yes.
And you can have as many gosh darn digit meters as you want.
Right. What would have digit beated 5 times? Right. Okay.
Very logical.
Yes.
To do it that way.
Okay. But anyway, the point is, if you're just going to tell that out to WinLink CMS servers, what's the point? See if you can put a radio on it, especially a front line. Anyway, other things you could do on the network. This didn't come across. This is my weather station. Runs the weather station is a Peak Brothers. All it has is a crummy little LCD and a serial port. So the serial port goes to a Raspberry Pi via USB, and I run a program called WWX. I don't know if it's WeWeather or WWX, but it's an open source weather station UI. Supports 2 or 3 operating systems and literally a couple hundred different weather stations and environmental sensors. Let's leave it like that. And you can, it's infinitely configurable. And this is on my mesh network. I FTP an image up to my cloud server, so I can see what the weather is at home anywhere. Not all about MCOM. We spun up a Scrabble server and played. Shoot 'em up tank game. I suck at it. I don't tell you, but it was fine. And we've played a few games of poker after that. Oh, and I just added this. Dave AI6VX in Ventura built his home-built seismometer a couple of years ago, and we just got it on the web or the mesh network. So if you'll see something shaking, you can check in there. Might be useful if the internet's down and this is still up. Was that a earthquake I felt? Or if you can't get to any of the internet sites, this will give you a little information. Not location, but whether it really happened or not. So hardware, what's available? Hardware supported by AREDN. Mostly designed for outdoor use, one exception. So it's weatherproof and power over Ethernet. You don't know what that is. There's 2 spare pairs in every Ethernet cable. One's power and one's ground. Each of them having to run up a separate power cable. There's 2 sophisticated software-defined transceivers in there. Half duplex radio and a wonderful modem that can change modulation protocols in a heartbeat from a per packet basis. And there are 2 of them because all these radios now are MIMO. That's multiple input, multiple output. One transceiver is connected to a vertically polarized antenna. Another one's connected to a horizontally polarized antenna, and they transmit data at the same time on the same channel. There's enough isolation where they split the data apart on the transmitting end, and they recombine it on the receiving end. They call it 802.11n. And if you're ever bored, go to Wikipedia and skim 802.11n. It's friggin' magic, I tell you. It's fascinating. And most of them have built-in gain antennas too. And just recently, they've adopted support for, I don't know, 20 or 30 802.11 AC devices, the next generation. They are more modern electronics, obviously, slightly faster. That wasn't the impetus for adopting them. It's getting hard to find 802.11n devices. The manufacturers are ramping down production of them. I have a bag of show and tell here. Get it up in a minute. So that's really old. In spite of having 2 antenna connectors, it's not MIMO. Remember that 600 milliwatts I mentioned, the power output? Anybody remember what a Linksys puts out? 60. You're 10 dB down from the get-go. And you got to run through lossy cables to external antennas. And it doesn't have enough RAM and ROM to take anything modern. This is primarily what broadband hamnet got developed on. But the AREDN folks moved away from that and them. And especially cordial too, but that's ancient history. So a number of you probably have these, the nanostations. They worked pretty well. They now possess the slowest CPU of pretty much anything that's supported. There's an older version and newer version, they're identical. And the older version is now on the sunset list. About, of those 100 I mentioned, about 20 are on the sunset list. So read it carefully before you put something up. This is what I recommend as a replacement. It's about this big. If you buy it, you only get this. So you have to clamp it on a pole. But if you need vertical elevation, you'd have to buy one of these. The mounts. Come on. Oops. The little one on the left is only $3 if you can find it to buy. The one on the right is $12 or $15. Those are Microtics. Faster CPU, more RAM, more flash, gigabit Ethernet ports. They're a pleasure to work with. That's a nanomean. Works very, very well. If you're familiar with the nanostations, they have two Ethernet ports. This is a dual Ethernet port version. So if you want to upgrade, you need two ports. This is your baby. It mounts with a single hose clamp right here, and it's got a wiggly mount you can tighten when you got it in the right direction. So on the left is Ubiquiti, on the right is Microtech, a couple different sizes. These look identical to the 802.11n. The only difference is in the radios, which is inside the plastic. The guys who are backfitting their Go boxes for digital or building digital only boxes like the Microtech because it's lighter and has less wind resistance, obviously, since you can see right through it. I just deployed one of these a couple weeks ago. It's about this big. Got a sturdy metal dish there. I don't see how they can sell that $75. Highly recommend it. I really like this.
Because they have the dream wall for 900.
I'm sorry?
It's because they have the dream wall for 900 and people buy it.
And if you happen to be in an HOA, you can put a Microtech light dish feed at the feed point of a satellite dish. And the LDFs only have about 9 dBi gain by itself. But you use a cheapy $8 universal LNA mount you can get from Amazon and put it at the feed point, you get 23 to 25 dB. And they'll never realize it's not pointed at a synchronous satellite. A few people using these. So, Microtech HAP AC Light. This is their first generation. By the way, HAP, I finally found out, is home access point. It's a 5-port router. If you load the AREDN software on it, it does all sorts of useful things, which I'll talk about in a second. And here are the two newer generations, AC2 and AC3. The HAPs have wireless radios inside them, 2 gig and a 5 gig, and they're gradually getting more and more utility business. And I'll talk about that. But the AC3 obviously has external antennas, and I'm told it has excellent coverage throughout a house, whereas the internal antennas on the AC2 and the HAP AC Light are pathetic. Anyway, here's how it works. Goes in your shack, 24 volts, got the AREDN code on it, and out port 5 is PoE, except for the AC2, plus DTD, that's device to device. That's the VLAN 2 protocol that goes up, communicates between nodes. If you happen not to have, well, let me rewind. Down here on port 1 connects to your home network. That allows anything on these 3 ports to go either out to the mesh network or out to the internet, which makes it very, very easy. You don't have to have a computer dedicated to the mesh network. Whatever you have here in the shack as a computer will work. If you don't want to wire it, you configure one of these radios as a wireless access client, connect to your home network that way. If you happen to be traveling, you can configure it as a home access. Well, let me rewind. This can be a home access point, and you connect your smartphone or laptop to it. Or the other one could be an access. Yeah, and connect to your home network. Handy, very handy. They call it the Swiss Army knife of AREDN networking. The older one, they have AC Light. I think it's 50 or 60 bucks. None of this stuff is expensive. Okay, so just like you wouldn't put a Baofeng up on a repeater site into production, a number of these devices I show you aren't appropriate for high-level sites. This is what you would use. What you see there is what they call a sector antenna, because it covers a sector of the compass rose. Typically 120, You can get 180s, 120s, 90s, 60s, and I heard of a 45. But inside there are two antennas. There's a vertically polarized 120-degree antenna and a horizontally polarized 120-degree antenna. And if you see them, here are the SMA connectors coming out and going to this, which is a ubiquity rocket. It just clicks on the back and you hook it up. If you happen to be at a hilltop site where you've got a user community here, the user community over there, you would not use an omni. You'd put a 120-degree sector this way, or whatever degrees were appropriate, and another one pointing that way. And you bring their Ethernet cables down to a network switch, and they exchange data that way. You put them on different channels, so you don't get the hidden terminal collision thingy that we deal with on packet. This is in North Orange County on a hill that shall be nameless. I think it actually is nameless. This is a quarter mile off the nearest dirt road. It's about battery and solar powered. It's got a 2 gig, 3 gig, and a 5 gig sector. And they have shields on them. That's why they look battered. Pan tilt zoom camera. I saw a video from this where he watched planes landing at John Wayne Airport. He zoomed way in on them. Very handy for fires and stuff like that. The little camera at the back, the bottom, is pointing backwards at the batteries and solar panels. Because he doesn't have a weather station there, he put a flat type thermometer on next to him, and that's what the camera's watching. So you can see how hot it is up there. So, a little hard to see. I need some different colors, but basically that's the coverage, network coverage here in Ventura County. Leave these slides around, see what it's got. Yeah, here's the one on Rasno Peak. It's got good coverage, except you'll notice down here is Newberry Park. And I'll tell you why. That little lump, it's about 600 feet down the northern slope, Rasno Peak. That's what's shadowing Newberry Park. And if Rob's interested, I did a coverage based on moving it over to the top of the tall tower there. Didn't help a bit. We're discussing how to improve that, but no decisions yet. Fortunately, here, this is Rasno Peak, the mesh gear. Stop it. I need to get my green pointer back. Anyway, this is the dish that's the backbone link. It goes to, let me think, Camarillo Hills. And this is the sector antenna, 120-degree sector antenna. There's the rack that's inside there. Rob, is that the boson repeater in that building? Okay. Is his UHF repeater in there also? Okay. So anyway, that's what's in the rack plus a network switch. And on the other one, you can see the lightning suppressors. At the end, the coaxial ones are at the top and the Ethernet ones are on the bottom. By the way, he runs double shielded Ethernet cable everywhere on the mountains. Very conservative. So even if you can't see Rasno Peak, all is not lost. Over here is a South Mountain node, and here's the coverage. Now, these coverage maps don't know anything about trees or buildings. This is the ground level, it assumes everything's flat. So if you're interested in one of these, there are any number of line of sight calculators where you can put in both ends and figure out if you can see one of these. Because it is truly line of sight, folks. No knife edge or refraction on 802.11. So that's this is what we used to call South Mountain. Because we have two South Mountain sites now, this is known as West South Mountain. This is the old Gunderson site. BPK, Art Gunderson. He passed away a number of years ago. His family owns it. The sky. Yeah. Anyway, you see the sector antenna on the top on the right, and the dish on the left, and there's a pan tilt zoom with a very thick top. So that's West South Mountain. I didn't get a picture of the building, but it's not very memorable. Oh, the dipole antenna at the top, the loop dipole, that's the 6 meter repeater. That's up there. About a year and a half, 2 years ago, Paul, who makes friends with everybody in high places, made friends with a WISP, wireless internet service provider operator, and he had purchased those two buildings on the left. They were almost unused. The one on the right had been completely abandoned for years. It's pretty icky. So in exchange for site equity, sweat equity, cleaning up the site, we cleaned out, well, partly the building on the left, mostly the building on the right, sealed up all the holes, placed a dead vent fan, and occupied it with equipment. Inside that equipment is equipment not only for CVARC, but for DARN, the Disaster Area Radio Network. I think that's our best PTZ camera up at the TV dock. Down just north of that site, I don't know, 20 yards, and down about 30 or 40 feet is another plateau with these two rusty steel poles on it. On the top are two sector antennas. The one at the top is pointing at Fillmore, and the one on the bottom is pointing southeast to replicate the southeast one from west Southland. Unfortunately, both the radios and those are off the air because they got subjected to a over voltage. We have the replacement radios, but who's got time? Down at the bottom, the big dish is the 5 gig link to Camarillo Hills, and up at the top is the northern end of our experimental 10 gigahertz line. They finally got a final alignment between there and Verdugo Peak, 42.49 miles. It's a full duplex link. The aggregate throughput is 1.5 gigabits per second. That's about 600 megs, I don't know, plus each direction. It's not going to be strictly for AREDN. It's going to be an all-comers ham radio digital backbone. Paul told me now that we've got it working, he's working to just integrate it temporarily into the network. We're going to submit another ARDC grant request for enough of these radios to run them from the Mexican border to the Bay Area. Like all those people in high places, I can augment that with a few. So we sent an email out to them and say, hey, we send you a 10 gig radio, you want to put it up? Pretty much the answer was hell yeah. Because you do DMR, whatever digital mode you want, digital video, you got enough bandwidth. The cost for each end, 2 radios and 2 antennas, $2,400 per radio and antenna. Like that. They'll need grant money, but about a year ago, we told ARDC unofficially what we were planning on doing. The answer back was cool. So I think we'll be okay. It's hard to get up the hill. So KV6BYJ at the top is helping Paul, the V6EBY up the hill. This is inside. The repeater rack is on the left. Cavities at the top. One set of radios is link radios. The other set is repeaters. Below that is the repeater controller rack. And those cards are modular. There's one card in the rack per repeater. And you can tie them all together 9 ways from Sunday. You can't see it below there, but there's a network switch and other stuff. Behind the repeater rack is the thing in the middle, which is the power distribution unit. Boy, Paul does good work. It's professional. Upper left is redundant power supplies. On the right is telemetry. The red thing is a 150 amp breaker switch. The yellow things down at the bottom are power output. There's 3 there, 1 for DARN, 1 for CVARC, and 1 spare. On the right is a newly built cinder block battery box with not 1, not 2, but 3 LFP banks, battery banks. CVARC has abandoned AGM batteries and going forward to do all LDF. And there's, you can see the 3 little black things are circuit breakers, and again, there's a main cutoff switch, the red one at the top. Paul told me something. Those, let's see if I can point them out. These here, the wires, they're all the same length. to equalize the battery drop, the voltage drop. Is he particular or what? Anyway, here's a network map of Southern California. I didn't zoom in and get our area to get the idea. Last time I counted, there were about 425 nodes in that region shown there. The guys up in Central Coast are doing a good job pushing things hard. The dotted lines are internet tunnels, obviously. So orange is 5 gig. This is a memory test. Purple is 2 gig. Blue is 3 gig. Gray is no gig. That's a AREDN before the radios turned on. AREDN have AC light. Another thing we use, these are these PTZ cameras. That's north end of Sycamore and Simi. West end of Simi. We have 2 PTZ cameras. We only used to have 1. Well, they lost Chatsworth Peak, so we put the other one on the east side of the water tank here, so we can keep an eye on it. This is an older camera, South Mountain West. We have a really nice access camera on South Mountain East. We record them all. Where do you get the info? Your own website. List of supported products. By the way, in that entire list of supported products, up in the column on the right, you'll see if something says sunset. That's those 20 older ones. Give them a pass. Anyway, AREDNmesh.org. Production releases. We picked up a very talented coder a year and a half ago. And once he got familiar with the software, he's been turning and burning. So production releases have gone from 1 every 1 to 2 years to 1 every 3 or 4 months, and lots of nightly builds in between. You know how you start working on a project, a large project, and find something here needs to be fixed on your way to the finish. Oh, here's another thing that needs to be fixed. Here's another. You eventually get to the end, but that's his modus operandi. He'll find something subtle that's wrong, corner case, fix it. So we get a lot of nightly builds. None of them individually are a big deal, but as it goes on, the software is getting more and more stable. Not that it was unstable before, but let's say rock solid. Lots of how-tos, FAQs, extensive documentation. It used to be a mess, and about a year and a half ago, Steve, 87PA, says, I'm going to fix this. So he put it all into a GitHub repository, which technically comes in something called online docs, website for documentation. And he tracks every nightly build and updates the most recent documentation. Great setup, getting started, how-tos from that's, A to Z. Forums, about 4,400 active members. If you're on Facebook, the group there has about 2,000 members. If you're on Slack, there's an AREDN community. A lot of the very the heavy-duty guys hang out there. Or at my site, big deal. I have a beginner's guide PDF that's a summary of this. You can hand it to your ham friends who are mildly interested. I have a PDF version of this, and it's got all the pretty pictures, plus it's got all the words I've been talking in there. So the pictures mean a little more. And some other links to line of sight calculators, stuff like that. Any questions?
Oh, question. I got a question.
No, they know it all.
Question.
Yeah.
Question. Not directly related to the mesh thing, but the PTZ cameras. I see a lot of videos that have those. What kind of costs are on those?
Remember the phrase "and up"?
Okay.
The ones we buy, we've been using Sunba cameras for quite a while now. The early ones, the 405s, were not real good. And they required Internet Explorer 6 custom plugin. So anyway, we went to the performance series. There's a 625 and a 636. Under 300 for a good one. They're 48 volt. You have infrared. Oh, and I have them set up to patrol every few minutes. I'm gonna go over and do it again. And the websites, I can put that link up there. The websites, I have them on the mesh network website, and I mirror them out to the cloud server. So even if you're not on the mesh, you can go see what the cameras are looking at, and they change every few minutes.
Yeah, thanks. I was curious how much those are. I see a lot of them.
The access cameras, which we budgeted but we've only bought one so far. Are really, really nice. 330x zoom and image stabilization and heaters inside, keep them from fogging up. Good stuff. They're about $750. Not cheap. Thank God for ARDC. Now, by the way, the ARDC stuff is only the the grants are only for projects. CVARC has operational costs, rents. And so if you're inclined to throw money at CVARC for rent or other stuff like that, there's a GoFundMe? I think it's a Venmo account. Anyway, it's on CVARC.com. Any questions? This is good stuff. Yeah.
A while back, I remember that there were some issues with the routing protocols 5+ years ago. Were those finally fixed?
When Tim, the brand new, I gotta tell you this. There's a software programmer up in Berkeley, very competent, involved with a couple startups. He sold off, made a lot of money. In the spring of 21, he got interested in AREDN radio networking. So he got his license. That was in spring. In October, he issued his first patch that fixed the vast bulk of the stabilized the routing. And since then, he's made other tweaks. He's done like 90% of the updates now. I mean, he's retired. He's doing half the work. You know, he's a good guy. So yeah, it's so last October we did a link everything you can together and make it as large as you can. Called it Meshaween because it was on Halloween. And I think some sites saw a count of 1,500 nodes. And from that, we had no network problems, except it uncovered some software weaknesses in the AREDN code for large lists and stuff like that. And he fixed it. That being said, you're trying to display a list of 1,500 nodes on one of those old slow nano stations, you may be in for a few seconds leisurely. Yeah.
So most network connected services today, it's very hard to avoid encryption. And I know that's one of the FCC challenges here. So is this a kind of one of those don't ask, don't tell situations, or like how seriously is that taken and how do you avoid that problem?
It's like this. When I was getting interested in this about, 2015, 2016, I had a discussion with a lead official who said they had had informal discussions with the FCC about this very issue. Since then, there's been no formal discussion. Ham radio is suffering from benign neglect of the FCC. But at that point in time, the FCC told him, don't worry about it.
Okay.
And the attitude towards that thing varies from place to place. It ranges from, oh God, no, track down the HTTPS stuff and stop it, to, we leave it on all the time. So I don't worry about it. Yeah.
So are we running encryption? Because I can't see us being able to do any type of, HIPAA data or, anything sensitive in a disaster situation without that.
The network's transparent to any protocol. If it's HTTP, RTSP, RTP, it'll pass it.
Be running I think you said that we had encryption off.
We turned encryption off on the tunnels a couple years ago. I say we, I'm not part of the dev, but anyway, I hang with them. We turned encryption off, not because it's illegal to use it, but we're so desperate for flash space, I had to kick it out of the code. Eric spent months looking for things in that code that we didn't need, tossing it, making sure it still worked. And for that reason, those devices I said were on sunset. That's why they haven't been kicked out already. It's based on OpenWRT, which is the open source wireless access stuff. So wherever they go, AREDN goes. And if they stop support for those things on the sunset list, doesn't mean they'll stop working, but those will not be eligible for upgrades going forward. And a lot of them are really slow. I mean, you could drive a 65 Falcons from here to the East Coast, but why would you want them? You know, it's the same kind of deal. Because the stuff's cheap. I didn't mention, I said though, that one was $75, the half AC light, which you'll buy anyway. If you need it. It's another 75. If you have a long run of Ethernet up the tower, you'll pay more for the outdoor Ethernet cable. Like that. Now, I just said it's cheap, that's cheap for your shack. If you're gonna support high level site, you got 2 or 3 sector antennas, plus the rockets, plus the shielded Ethernet cable, plus a PoE network switch. Stu can tell you that the switches have gone crazy in cost. And hard to get. Oh yeah, battery backup. It gets to be like a repeater site, so support your local network.
Yeah, I know the ubiquity, you know, we switch in the smallest one's about 500.
But yeah, it's ridiculous. That's like what, an 8-port switch?
And I've got a 16, but
Yeah.
yeah.
Yeah, we switched to Netonics because they're the only DC powered switch you can get, and they have inverters in them. So they'll give you 12, 24, 48, whatever. But we had a couple we turned in for RMAs in January. Not only have we not gotten them back, the vendor we bought them from can't get an answer from the Netonics.
Oh, gee.
So we may be out a couple pricey. And we really don't want to run and curve AC UPSs on sites. We'd rather have DC. So anyway, it's a challenge every day, but it's fun. Any questions?
All right, thank you.